but let's solve this by putting this in triangular form. There are other ways to solve this, and you might have learned some different ones in Algebra 2. We want to solve this by putting this in triangular form because this is what's going to lead us directly to solving this using matrices. And that's what we're going to do next week, is we're going to solve these with matrices. But this is the process that the matrix will go through, that we'll go through with matrices to solve these. So I want to try it first. We're going to do it first, just with equations and without matrices here. So this is our system, and our goal here is to put this in triangular form. So I'll give you a second, make sure you write that down. That system. And then I'm going to circle, this is what I'm going to try to get rid of first. I'm going to just get rid of one thing at a time. I normally get rid of two things. I normally get rid of both these x's, but I did that first period and it did not go well. So I just want to do one thing at a time. So that's what we want to eliminate, that x right there, because that'll help us get in triangular form. You need to start with the x's. You can't start with the y. You got to start with the x's, and I'll show you why here in a minute here. But well, how can we eliminate that? I don't know. Maybe the easiest would be to take row 1 and subtract row 2 to get a new row 2. And that's exactly how we're going to write that. We're going to write our process. What are we going to do? Let's take row 1 minus row 2 to get a new row 2. I'll put that in row 2. We're allowed to do that. We're just adding a multiple of negative 1 there. So we're not going to change these two, so we just write those down. As I said, this is a bit of writing, but what you don't want to change, you just write down. And then now I think we can just do this in our head. Let's just subtract here. X minus x would be 0. Negative y minus y would be negative 2y. 4z minus negative 2z would be positive 6z. Positive 6z. 6 minus negative 14, so equals 20. So you have to be careful, especially if you're subtracting. A lot of times I'll add instead. If I have a choice, I'll add. Okay, so there's one step down. We're getting closer to triangular form. Our next step now is to get rid of this x. So if I take row 1 minus row 3, that'll make my new row 3. And there's several reasons why we write out what we're doing. And first of all, I guess I should make sure you know this is row 1, row 2, and this is row 3. They're really equations. That's really going to make more sense when we do this with matrices. But I just want to keep the same notation here. But the reason why we really need to write out what we're doing is, number 2, there's multiple ways you could do this. And if you want me to try to help you, there is no way when I look at your matrices here, if you don't have written your procedure, there is no way I can go back and try to figure out where we made a mistake. And not even me, there's no way you're going to have trouble going back. If you don't get the right answer, you're really going to have trouble going back and trying to retrace your steps and figuring out what you did. So that's why we want to get in the habit of, writing out what we did. Well, let's see, anything that we didn't change. The only thing we're changing is row 3. So we can just write these down. So I'm just changing one thing at a time here. So now we said we're going to take, if we take row 1 minus row 3 to get a new row 3. So x minus x would be 0. Negative y minus 2y would be negative 3y. 4z minus 5z would be negative 1z. And 6 minus 6 would be 0. Well, right now, our goal here, we eventually want to get rid of this negative 3y. Well, do you see how I am not able to go back to the first equation? Because if I add that first equation to that, I'm going to get my x back that we worked really hard to get rid of. So we can only use these two now for this one. And this is going to be sort of a pain. Because, I'm going to have to multiply by, I could do 3 halves. I could multiply by 3 halves, but it might be, do you see how to get these to, that's where negative 3 halves even would make it easier, but I don't even want to do that. I want to just, notice how this is all multiples of 2. So I could just take row 2, and let's take that times 1/2. If we take that times 1/2 to get a new row 2. I just wanted to show you that you are allowed to do that. You're allowed to take a row. You see, if I just multiply that by 1/2, so now I have x minus y plus 4z equals 6. So this would be negative y plus 3z equals 10. Do you see how that's going to make that easier now? Because now I'm going to try to get rid of this. I want that to eliminate that. I can only use the second and the third rows here. So, I don't know, what if we take the row 2 and multiply that by, I don't know, we multiply it by negative 3? If we multiply it by negative 3, then all we would have to do is add. So plus row 3 would give us our new row 3. And now this is where everything else we've been able to do in our head, and many of you can probably still do this in your head. But if not, let's go ahead, we can go ahead and write this off to the side. Let's go ahead and take row 2 times negative 3. Well, let's see, that's going to be 3y, positive 3y, minus 9z equals negative 30. And then I'm going to add that to row 3. So right under it, let me write row 3. And then I'm going to add those together. And when I do that, let's see, that's good. That eliminated. That's what I wanted. So I get negative 10z equals negative 30. So let's write this. Should be the last time we have to write this now. No, I don't need, I can fit it on here, I think. I have x minus y plus 4z equals 6. Negative y plus 3z equals 10. Once again, if I didn't change it, I have a new row 3, but that's all. My new row 3 is negative 10z equals negative 30. Is this in triangular form now? Yeah. Does that look like one of your problems you did on that Google sheet? Very similar. So now we can just do back substitution to solve this. Well, z is going to equal 3. Y. Someone help me out there. What's y? Z is 3, Y would be what, -1? Okay. And then what would X be? -7? And usually for an answer, like on the quiz or something, I'll be asking to see two things. I want your answer, and then I want to see your triangular form. I want to see your triangular form. It could be a little bit different depending if you took, do you see how we could have chose some different algebraic manipulations to get triangular form. But I want to see that you did go to triangular form, and then you should get exactly the same answer. Well, let's look at the handout. If we look at the handout, there's a few examples on there that I want to go through. I'll just go through 1 and 2 with you, and then we'll finish the rest maybe in class here or for homework if we don't finish it. Here's number 1 on the handout. And once again, our goal is to get this in triangular form. Well, they gave us a head start here. This is already gone. There's nothing there. So this is what I'm going to focus. And I like to circle what I'm trying to key in on, what I'm trying to get rid of. And so I'm trying to get rid of that -x. So what can I do? This one's even easier. Just take row 1 plus row 3 to get a new row 3. So whatever we're not changing, we just write down. And now I don't think we even need to write this over to the side. I think we can do this in our heads. X plus -x would be 0. -y plus y, oh, that's going to be 0 also. -z minus 4z, so get -5z equals 3 plus 7, or 10. Well, we are already in triangular form. You see how we're missing this, this, and this? We're already in that triangular form. So now we can just do our back substitution. This doesn't happen very often that you can do the whole thing in one step. But so what is this, -2? What did you get for y? 3. And what did you get for x? What did you get? Sorry, I'm just not hearing very well. Did you get that? What'd you get? Somebody really loud. Liddy, what'd you get? 2? Anybody else get 2? Nope. X minus 3 minus -2 equals 3. So we have x minus 1 equals 3. So x equals 4. All right. Thank you for. So we get 4, 3, -2. Is that what you got? I'll do one more with you because there's some question.
For that one, I don't guess like the triangle thing, but out of curiosity, could you like set it equal to, so like since this one specifically doesn't have an x in the second one, could you set that equal to z and then set another one equal to x and then plug that in for the third one?
To solve this algebraically, yes. There's a lot of different things you could do to solve this algebraically. You could take 2 at a time and eliminate the same variable. You could do the substitution that you just said. Our goal today is to practice trying to get this in triangular form, just because that's going to lead us directly to what we're going to do with matrices. But you're right, yes, you could do that. Yep. One more. Let's look at number 2, and then I'll let you work. But there's something different about this second one. So let's see. So here's the second one. Let me write this down again. I really have trouble. I have to, if I don't put that line through my Z's, I keep thinking that it is a 2. I used to do them in cursive, and oh my gosh, the students had no idea what I was doing. They're like, what is that? So I went back to the German heritage here. Well, okay, so our goal here is to put this in triangular form. So I'm going to start here. We have to start with the x's. You'll really mess yourselves up if you start to try with the y's, the y value. So let's just start with the x. And so let's see. What should we do to get rid of this? How about if we take row 1 minus row 2 to get a new row 2? I think we can do 2 steps at once, or should we just do 1? Okay, just do 1. Okay. So that's the only thing we're going to change. Yeah. Okay, so what we're not changing, we just write down. Okay, you can write this down if you want, but I think we can do this in our head, the subtraction here. Just be very careful. X minus x would be 0. Good, that's what we wanted. Y minus 2y, so negative y. Negative z minus negative 3z, so plus 2z. 0 minus negative 3, so positive 3. Once again, you just have to be very careful. Take your time with the signs there. So far, so good? One step. We're a third of the way there. Now our next goal is to get rid of this 2x. So let's see, how about if we take row 1, multiply that by negative 2, add it to row 3 to get a new row 3. That looks like a good plan. Once again, that's our plan to get that new row, to eliminate that 2x. Equals 3. Okay. Now this one, let's go ahead and write this one down. Let's see. So if I take negative 2 times row 1, so that'll be negative 2x minus 2y plus 2z equals 0. And I'm going to add that to this row 3. I'm going to add that. And then let's see, good, I eliminated the 2x. That's what was my goal. And then here I have what y minus 2z equals negative 3. And that's going to be our new row 3. We're getting there. So we have one more step to go. Now we just have to get rid of this Well, this looks pretty easy. First of all, we can only go to 2, row 2. Once again, you cannot go to row 1 because you'll get the x back. But row 2 looks really easy. We're just going to add these together. We're just going to take row 2 plus row 3 to get our new row 3. If we add those together, we'll eliminate that y. Once again, any row that I'm not changing, I'm just going to write down. Okay, and I can just add these together without writing it down. Negative y plus y is 0. 2z plus negative 2z is, also 0. 3 plus negative 3 is also 0. So I have 0 equals 0. If I wanted this in triangular form, I could really say, that 0 times z equals 0. So, well, this is going to be an infinite number of solutions here. So this has infinitely many solutions, or an infinite number of solutions. But they're not random. Again, they're not just, we can't just say they're any numbers. I mean, they're not any real number. I mean, you can choose any real number for one of them, but there is a pattern that they have to go in. And so if I want to write this solution here, well, first of all, z can be anything. I'm just going to put z. But now y, we know that negative y plus 2z equals 3. So let's see, if I solve this for y, I'm going to see add y, subtract 3. You see how y would be equal to 2z minus 3. So my z value can be anything, but then once I choose that, my y value is going to be 2 times z minus 3. Well, my x value, let's see, I have, here we go, x plus, well, what is my y? 2z minus 3. I'm just going to take the y out and put in 2z minus 3 minus z equals 0. So if we solve this for x, let me just write that x plus z minus 3 equals 0. I add like terms, and then x would equal negative z plus 3, or 3 minus z. You'll see it written both ways sometimes. Some people like to always put the letter first. Some people never like to have a negative first. So how about if I do negative z plus 3? And that would be what our infinite many solutions would look like. Okay, there's an infinite number of solutions, but then this is the form that they would take. Does that make sense? Try number 3. Try number 3. Your homework then is going to be to do 3, 4, 5, and 6. And I guess I should say here real quick because one of these last 4 is no solution. No solution, you know how here we came up down with 0 equals 0, which is a true statement. If we would have come up with 0 equals 7, then it's just no solution. And you don't have to write any fancy solution there. You just write no solution.